Hello everyone. Today I'm going to talk with you about object-oriented principles, and we will describe every principle in our code. Let's start from the first principle, abstraction. Abstraction. What is this principle about? This principle is about hiding uh, elements in our classes and showing only what do our objects, our classes, like so. We don't need to know, for example, how TV works. We only need to turn on button, turn off button, and just watch a movie. It doesn't matter like what happens inside this TV. So let's create, for example, class vehicle, and product constructor, for example, with a property brand, and this is brand, and what's important for us is this: we don't know we can we can have like realization here, uh, and realization of how our vehicle works, like inside, like engine power, and uh, actually, yeah, like engine power. Like we can add engine power. I think it will be already part of the engine, but doesn't matter. Like we can have a realization here, and but what we need to know that our vehicle is moving. So we just can write like here, like console log. It is moving, and that's it. For example, it is moving, and that's it. So the idea is that user, when we create our like, we just use and like we give users and to use only one method move. And the thing is that, for example, like it is moving, like we can describe it a little bit in the other way. The problem with JavaScript is that JavaScript doesn't have the like protocols or interfaces, which is more clear, with which it will be more clear explanation of abstraction. We can, for example, say it this way, like throw new error. For example, this way, and create a new class. I'll explain what I did. So we have our, and it is one of the ways to explain what is abstraction, is to create abstract class, for example, vehicle, and just any vehicle, and we do want to put other classes that extends this class, or like inherit from this class. They should have this method. So like we want, like we, it doesn't matter what other classes will have like inside realization, but we do want to these classes to have like methods as move, or like I don't know, yeah, like move, for example, yeah. So it is the idea of abstraction, like I hope I explained it. Let's continue, and we can talk about what I already did actually, about inheritance. So what is inheritance? It is a way of making our code more clear, or not to repeat. And we know that, for example, car is a part of vehicle scope, and we want to create our car. Want to create our car class to explain what it does, but we already have vehicle class, and maybe we'll have other, like maybe bicycle or something like that, which is also vehicle. And we can create class, car class, and bicycle class. Sorry, bicycle class. Bicycle class, and write similar methods here, but and all of these classes will be different, like will be unique. But actually, the correct way is to do that is to use extends word and inherit these classes from vehicle class. So by that we are later we can work with vehicle class and use our bicycle and car classes, and also know like the main realization, like the realization, like I would say like by this way we are able to reuse and some methods, and we don't need to copy it. That's the idea actually of inheritance. Like we can use an interface of our parent class in our child classes. So let's go ahead to encapsulation. And in encapsulation, the idea is that we want to not permit to get some properties in our class. For example, car can have property I don't know, like documentation, I don't know I don't know why, but documentation, okay? There's property documentation, and let's say documentation about this car. Documentation, and like when we create a car object, for example, let car object equals new car, we say brand BMW, and I don't know, like and some documentation. And then we'll try to get this documentation from our object. We just write documentation here, and we'll get this object. I'll copy bicycle, and we'll get this object in forget this object property. So some documentation. But if we want to hide information about some properties or methods, we need to use hash here, and by that way documentation will be inaccessible. So if we'll try to get documentation, we already see like error here, but if we'll try, it will say us this private field. So by this way we're able to hide some properties and methods which we don't want to show off. So it's really good to use. It's like, let's say, obligatory to use. So yeah, and for example, in TypeScript you just write private word, and since there are public variables and methods are private, and it's very comfortable to understand like which properties you use inside of your block of code, and which properties you need to show outside to give access to them. So let's go to the second one. The fourth one. Principle is polymorphism. Polymorphism. So what is it about? It is about the different classes can have the same properties, and if these classes are inherits from the same class, we're able to work with these classes if it were this class. Okay, maybe a little bit complicated to explain, but I'm going to write the code. Like we already did with our car. Let's add the bicycle. Correct. Let's see, bicycle. Okay, sorry. Bicycle. And then bicycle, we're going to change our move method. For example, we say that here that this bicycle speed bicycle. Let's say bicycle and bicycle speed. Let's say 20. Here, yeah, that's it. And we'll let these properties now console. So let's say okay. So, and if we want to work with, like, we can create objects like car object and bicycle object. Okay, we already have car object. Let's create bicycle object. New bicycle. Okay, brand. I know, like the bicycle brands actually. I don't know. Wow, let's say wow, and documentation. Just any, and if we want to, for example, to work with let we want to and if you want, for example, to work with uh, methods of this object, like okay, and right now let's create, for example, const const let's sorry, const array, like how's it, vehicle array, and we can say this new, like this car object and bicycle. Yeah, because they are the same type. And right now we can work with this vehicle array. For example, array, we can say for each vehicle, we want to use move method. So let's say vehicle move, and we're going to see that we're able to work with every, like if it were the same class, but they're different classes, but because they are inherited from the same class, we're able to work with them, and it is the main meaning and describing of polymorphism, so we are able to work with them as if it were the same class. So I think we're going to talk about solid, which is also useful to know how to write code correctly. Let's start from the first letter, S, singular responsibility. Singular responsibility principle. So the idea is that every class should be responsible only for one action, one thing. So for example, we can create class user, constructor, the name, full name, and this name, equal full name. Yeah, and user can do different things. Like for example, user can, for example, send let's say send emails. Like you can send emails, and we're writing here send email, like so send email, and it is actually incorrect way to write user class. Like user can send emails, but it is not like his main responsibility. He's just a user, and we should to describe user. Actually, emails are sent by email server, so we need to create the email server. We need to create, like it's better to create another class, and just like without constructor, and this class will already have send email method. So the best way is to to make it that one class should have one responsibility. Let's talk about next one. Opened, closed, principal. The idea is that once we created our class, we're not going to, like, even if we need to add any functionality, we're not going to change this class. Like, we're going to extend this class. For example, like, we can say above, we created the email server. And for example, then I decided our email server also can print these emails. So we're going to create class print emails server. It extends our email server. And here we're going to print email. So just receives email, or like sends, or get email, and then print email. Just imagine this, I don't know. So, let's see. Yeah, like print email. So we didn't change our class. Like, that is that our closed means like it is close to be changed. But it is open to be extended, to extend. So it is the main idea of open close principle. So let's talk about the next principle. It's called substitution principle. So it's called. Let's just leave it this way. And the idea is that we can use the functionality of some methods, of some functions, by, like, we can say that this function takes this type, and for example, a type of parent class, and we can use childs of this parent class for this functionality, for this function, and without changing anything, just using these childs, and that's all. So, and it's a little bit complicated to explain by words, so I'll just write the code. Let's say that we have a notification class, and this class send notification, message. It's a message. It's a message. We have SMS notification, which extends from notification, and it also sends a message, but it is SMS message. Let's say that we have email notification. It is email message. And we have a function. It works with notify. Let's say notify. This function takes notification, accepts notification variable and message variable. We say that notification send message. So, and right now we can create two objects of SMS notification and notification. Let's say SMS notification, and let's say email notification. So, and we can use notification, SMS notification, and our message, let's say, hello, it's me. Okay. And hello, it's me. And here's the same. Already with a mail notification. Let's see where I made a mistake. Can you? Yeah. Okay, again. Send notification, send message. Send function. Sorry, I lost SMS, email, sure. So you can see that it is SMS and it is SMS, hello, it's me, it's email, hello, it's me. So we didn't change anything, like we just use like notification as parent type, and we use child types without changing anything. So that's the idea, like to have structured code and where you don't need to change anything and work in this comfortable way. So let's continue and go to the next principle. So the next one is interface integration principle. The main idea of this principle is to use small interfaces and not to use big ones. For example, if you want to create, what happened? If you want to create a class worker, which can walk, for example, and worker also can eat. Yeah, it is incorrect. Like we need to create like first of all we need to create a workable class. Let's say workable. In this class we have this method work, and we need to create an eatable class. Eatable will be eat. And sorry. And then we need to create our worker, class worker, which extends our workable class structure, and here we'll create this eatable. It will be new eatable. And here already add eat class that will be realized by this eatable. So the idea is to divide as much as possible and logically, and if it is logically, our big interfaces to small one, and then extend them, inherit from them, to make it more flexible, our code. So let's go to the next one. And the last one is about dependency inversion principle. Actually, it is about that we need to plan, we need to think deeply about how to create our abstraction classes and interfaces to make them correct. Um, let's say that we have a light bulb and we say that we can turn on this bulb, and we can turn off. But actually, the idea is that we turn on and turn off switcher, and we don't turn on and turn off bulb. So we need to write class switchable, switchable, which is turn on, turn off, and then already extends switchable, and right here turn on console. Light bulb is on. So and do the same here is off. So we should write correctly our interface and correctly describe our class. And actually, this is the main idea, like to make better our interfaces and to think deeper about how to describe, how to write our code. So you should first think about it, like what is it is we working, and how to describe it correctly, because maybe later we'll need these switchable methods in other classes. So yeah, that's it.